Hi guys, welcome to the second episode of our quantitative chemistry. So we have already managed to calculate the formula mass. Now we're going to look at calculating percentages of elements in compounds. It's easier than it sounds, I promise. So let's think about percentages in the normal world before we go into the crazy quantitative chemistry world. So imagine I have a bag, and inside the bag I have 6 grams of blue sweets and 4 grams of red sweets, and I want to know what percentage of my sweets are blue. What piece of information do I need to know in order to answer that question? Well, first of all, I need to know the weight of the entire bag. So that's the first thing I want to know. How much does it all weigh? And then I want to know how much do just the blue sweets, it's the blue sweets I'm interested in, so how much do they weigh? Once I know both of those pieces of information, I take my weight of blue sweets, the ones that I'm interested in, divide it by the weight of the bag in total, and multiply by 100. So in this case, I know I've got 6 grams of blue sweets. The whole bag must be 10 grams because I've got 6 grams and 4 grams, add it together, 10 grams. So 0.6 when you divide 6 by 10. Multiply it by 100 and you get 60. So 60% of my bag of sweets is made up of blue sweets. So I needed those two pieces of information, the weight of the bag as a whole and the weight of the sweets that I was interested in. So how would you answer this question then? What percentage of hydrochloric acid is made up of hydrogen? Well, it's exactly the same as the sweets. I need to know two pieces of information. First of all, I need to know the weight of the whole thing, just like I need to know the weight of the whole bag. So I need to know the weight, or the mass, of hydrochloric acid. I also need to know the mass of hydrogen. Where do I find that information? Periodic table. So, to find the percentage of an element, you need the relative mass of the element, the top number on the periodic table. You divide it by the relative formula mass of the compound, how much the whole thing weighs, just like the whole bag of sweets. And then you multiply by 100 to get your percentage. Okay, so here we go. Let's go through it bit by bit. First of all, I need to know the relative mass of the element. That's like the mass of my blue sweets. I know for hydrogen it's 1. That's the top number for hydrogen. The relative formula mass, how much the whole thing weighs, that is 1 plus 35.5. Sorry, it's done a little shuffle over there. So that makes 36.5. So the 35.5, that's the mass of chlorine, if you look at the top of the periodic table, and then it makes 36.5 when you add 1. So what do I need to do now? Well, I need to do my 1 divided by 36.5, multiply it by 100. If I do that, then I get 2.81. So 2.81% of hydrochloric acid is made up of hydrogen. Okay, let's try a bit of a trickier one then. So here we're going to look at the percentage of propene, which is made up of carbon. Now we do this in exactly the same way, but we do have to be a bit more careful because in this case we've got 3 carbons and we need to take all of them into account. So what we need to do is exactly the same. We know that the relative mass of carbon is 12, but we're going to need to remember to multiply that by 3. The relative formula mass we find by adding together our 3 carbons, 12 times 3, and our 6 hydrogens, 1 times 6. You get 36 plus 6, which is 42. So then, remembering to multiply that 12 by 3, we do 36, the mass of our carbon, divided by 42, the relative formula mass of propene, and then we multiply by 100. And you should find you get 85.71. So 85.71% of propene, that's made up of carbon. Give this sheet a go now. Do be careful. I know that we've got some down the bottom that have got extra little elements in them. So down the bottom here you find that you don't just have your H's attached to your nitrogen, you also have an H attached to oxygen as well. So don't forget to take that one into account. The same with this first question here. You've got more nitrogens than you necessarily expect, so do keep an eye out for that, okay? Fab. Give that sheet a go. Pause the video here. Excellent. So if you've managed to do that sheet, then so far we have calculated the formula mass and we've calculated percentages of elements in compounds. So what we need to do now is be able to define what an isotope is and explain why some elements have masses with decimals. So what I'd like you to do first of all is make a note of some of these terms. They're really key, really important terms for quantitative chemistry. And if there's anything that you're not sure of, it'd be really good to have it written down. So it might be a good idea to pause the video here and maybe make some flashcards using these terms and their definitions. So, first of all, what's an isotope? We're going to look at two different atoms of chlorine and see what you can see. So here we've got chlorine and here we've got another chlorine. Two different types of chlorine. Why are they different though? Well, let's have a look. Here the chlorine says 35 at the top, whereas here we've got 37 at the top. So what does that tell us? Well, the protons don't change. Electrons don't change, that's 17 as well. But the neutrons do change. So for each of them, they have a different number of neutrons. So that's the really important thing. If you have two isotopes, the number of protons don't change. If the protons change, then what you've got are two different atoms. If the neutrons change, then you've got the same atom but different isotopes. So isotopes are two atoms from the same element which have the same number of protons and electrons but a different number of neutrons. That means they also have different mass numbers. It's really important that you know that. Most elements have several isotopes and the mass number is shown on the periodic table as an average of these. So, for example, here's our chlorine. In existence, 75% of chlorine in the world is chlorine 35. Only 25% of chlorine is chlorine 37, but it's still that quarter is still there. So, to get the average that we see on the periodic table, obviously chlorine doesn't have 0.5 of a neutron or 0.5 of a proton, it's an average. So we've done 75 multiplied by 35, because 75% of chlorine in existence is chlorine 35, and then added 25 times 37, because 25% of chlorine in existence is chlorine 37. Divided the whole thing by 100, and that gave 35.5, and that's the average mass number that you see on the periodic table. So if you see any points, any decimal places anywhere, this is what they've done. It means that there are isotopes of that element and that it's been averaged out. Okay, so now we've managed to calculate the formula mass. We've calculated percentages of elements in compounds, we've defined what an isotope is, and we've explained why some elements have masses with decimals. The last thing we need to do is to carry out some calculations to find the number of moles